In this video, we are going to do these three questions from the chapter probability. And this question also involves application of some formulas that you have done in class in the chapter set theory, right? In the chapter set theory, that means this is PA union B is equal to PA plus PB minus PA intersection B. We'll also be using Venn diagram. We'll be also using Venn diagram, particularly in these questions to do these questions. So let's begin with the first one. In this question from the chapter probability says three letters are dictated to three persons and an envelope is addressed to each of them. The letters are inserted into the envelopes at a random so that each envelope contains exactly one letter. And what we have to find out is the probability that at least one letter in the envelope is proper. So what you can do, as you can see here I've marked L1, L2, L3 as the letters and E1, E2, E3 as the envelopes. Now, let's do one thing. Let's say in the first go, what I'm going to do is to pair L1 with E1. Let's say I paired it, right? So other two letters can be paired number one in this way, right? So let's once again do fixing L1, E1, fixing L1, E1, right? What you can see that the other two letters can be arranged like this. That is L2, E2 and L3, E3. Now continue fixing L1 with E1. Continue fixing L1 with E1. The other possibility, that is the second possibility, will be like swapping them. This time I'll keep this arrangement, right? So this is the second possibilities with pairing L1, E1, right? Now, next I'm going to fix. Now I have fixed L1 with E1, right? Now I'm going to fix L1 with E2, right? Fixing L1 with E2, L1 with E2. So if I fix L1 with E2, the other two letters can be arranged like this. That is L2 with E2 and L3 with E3, as you can see over here, right? This is L3, E3 and L2, E1. This is what I have written here. So when this get exhausted, what you can do, there is one more ways, that is keeping this fixed, right? Keeping this L1, E1 fixed. Now we can do what? We can swap them. This is what? The second way. One more time. L1, E1, E2 is fixed over here. The other two combination was this. That is L2, E3 and L3, E1. L2, E3 and L3, E1. There is one more possibilities. Now this time what I'm going to do is to place L1 with E3, right? L1 with E3, then we have two possibilities. That is, one more time, fixing L1 with E1. So the other two letters can be fixed like this. That is L2, E2, L3, E1, L2, E3, L2, E2 and L3, E1. And continue fixing this. We have continue fixing L1, E1, sorry, L1, E3. What you can do, you can swap them. Let's say if I swap them, right? So this is the total possibilities of arranging them. Now, but when I read the question over here, they say that at least one letter is in proper envelope. So I can see this is at least one. So actually all of them is correct, but we just need to see at least one. Then this is at least one, and this is at least one. Then this is at least one. So you can say over here that this is at least one, this is at least one, this is at least one, and this row is at least one. So out of 6 such cases, we have 4 such cases where there is at least one letter is in the proper envelope. So it's 4 over 6. That can be reduced to be written as 2 over 3. That's how we will do this question. In the next question, he says A and B are two events such that probability of occurrence of A is this, B is this, and their intersection is given. The probability of their intersection. Now, what you have to find in the first part is PA union B. So what we know from the formula, that is PA union B is what? PA union B is this, that is PA plus PB minus PA intersection B, right? So we know this, that is PA union B is equal to PA plus PB minus PA intersection B. So simply we are going to replace these values. So we have P as how much given? 0.54 plus PB, which is 0.69, minus PA intersection B, that is 0.35. So we can add these two and subtract. So it should be what? 54 plus 69 will be 123 minus 35 should give you 88. That means 0.88. 0.88. Yeah, that's for the first part. Then what we have to find in the next part, this is PA naught, B naught. So from probability, what you know that if you remember A naught intersection B naught is what can be written as PA union B whole complement, which can further be written is what? This is whole complement, which is what? P1 minus A union B. So that results to give you 1 minus 0.88, 0.88, right? So it should be how much? 0.12. Yes, it should be 0.12. Right. We got these two. Now we have more. Let's see the next part. In the next part, we have to find that is A intersection B naught. That can be understood better with a Venn diagram. Let me use Venn diagram. So let's say if I take a Venn diagram over here, not this one. All right. I took one Venn diagram and this representing A and this other circle blue one representing B. So what we have to find out, intersection of A, right, with B naught. So it means that from this whole A, right, or let's say if I use this, from this whole A, this is whole A, right? And but what we need B naught. That means it should not have B, right? So if I say if it is B naught, then we have to remove this portion. We have to remove this portion, isn't it? So that way, what we can say, the required probability will be, I mean, for this part, right? I can say from here that is PA intersection B naught means from PA, we are going to remove their intersection. Well, everybody knows, I suppose, this is A intersection B. So intersection B, right? So this way we'll get. How much is PA? PA is mentioned at, this is mentioned 0.54. 0.54 minus their intersection, this is 0.35 minus 0.35, and their difference is how much? 0.19. Okay, we have more part, one more part, similar to the previous, I suppose. Look into this one. We are now on the fourth part. And in the fourth part, what is the case here? B intersection A naught, like similar to the previous part. What you can see that this time we need B, right? We need whole of B, let's say. From this whole B, if I remove the part of their intersection, right? This is whole B. As you can see, B should be there. Intersection with A naught. That means we have to remove the part of A naught. And A naught is this, right? I mean, A naught, I mean to say that common region of A naught. One more time, what I was saying is that now in the fourth part, which is very similar to the first part, so this time it is B, this time it is B, but not B intersection A naught. The same way, that is from the whole B, if we remove the intersection, that will results to give you, that should results to give you BA intersection A naught, right? So that same way as we did the previous part, we can subtract their intersection from PB. So if I do it over here, I can say from here, if I do, let's do it over here only. So from here, I can say this is equal to what? PB minus A intersection B. And how much is PB? PB is 0.69. So this is 0.69 minus their intersection, which is 0.35. That results to give you how much? 0.69 minus 0.35, right? So that's actually 69 minus 34 also you can do. So it should come as 30, 34, right? 0.34. So this should be the answer for the what part? Fourth part. In this question from the chapter probabilities is if four-digit numbers greater than 5,000 are randomly formed from the digits, and we have these digits 0, 1, 3, 5, and 7. Now, what is the question here is what is the probability that the number so formed is divisible by 5? And we have two cases when the digits are repeated and the other case when the digits repetition is not allowed. Now, let's begin with the first part where the digits are repeated. What you have to remember that we have to frame a digit numbers which are greater than 5,000. So you know that's a four-digit number, and for it to be greater than 5,000, it should start with among the digits given, right? It can start with either 5 or 7. So you can see that we can place this slot, right, by two ways, two possible ways, either 5 or 7. Now, for a number to be greater than 5,000 is the only condition we are taking as of now. We can see that out of the digits, how many digits we have? These are 5 digits. One of the digits, either 5 or 7, is over here, right? But then since repetition of the digit is allowed, this can be filled with 5 different ways. This slot as also can be filled with 5 different, any 5 digits can come, and this can also come in filled with 5 different ways. So we can see there are total of 25, 125, 250. There are 250 possible ways of framing a number which is greater than 5,000. But we are over here need to focus that there will be one such number, right, which is not greater than 5,000 among these 250. That is this one, right? If I write 5,000 over here, you see this 5,000 is among those 250 numbers, 250 such numbers, which is, you can see that it is 5,000, but not greater than 5,000. Look into this. We have to form greater than 5,000. So we'll have to remove one such number. So we now finally can see there are 249 such numbers can be formed which are greater than 5,000 using this digit. Now coming to the probability part, in the probability, we have to frame which are divisible by 5. Now we know that for a number to be divisible by 5, the n digits, let me erase remaining part. For a number to be divisible by 5, this n digits can be either 0 or 5. So here we have a restriction that this slot can be filled, that is a unit digit, can be filled in two different ways. And what about this condition remains the same? This can be filled either with 5 or with 7, right? The same way as we know that we have to find a number which are greater than 5,000. So we can say that this slot again have two possibilities, two ways by which it can be filled. Now for the remaining, as you know, repetition of the digits are allowed. So we can write 5 and 5 for these two slots in the middle. So it comes out to be how much? 25 into 4, that is 100. But once again, here also we have to subtract 1, because here also, you know, by placing, say, instead of 7, if I place 5 over here, and 0 and 5, out of 0 and 5, if I place 0, then we will have one such number called 5,000. So we have to remove this. That is, now we can say there are 99 such numbers, right? This is 99 such numbers. So there are the required probability will be 99 over 249. So is it divisible? 25 into 25. No, it's not divisible. So we can say that the required probability is 99 over 249 for the first part. Now coming to the next part, in this case, the repetition of digit is not allowed. So just look into how many such numbers can be framed out of this which are greater than 5,000. The only condition as of now we have taken is greater than 5,000 and not divisible by 5. So we can say that here too we have the same condition that it should start with the letter 5 or 7. So from here we can say the only condition is that it should be greater than 5,000. So we can say this slot can be filled with two ways. Now out of this 5 or 7, we could have taken only one, right? Maybe 5 or 7. So we are discarding any one of them. We can say we are out of the 5, we are still left with 4 digits. So we can say that this slot can be filled with 4 ways, right? This one. This can be filled with 3 ways, and this can be filled with 2 ways. So 4 into 3, 12, right? So once again, this is can be filled with 2 ways. We have 2 choices from here, but you know that out of the 5, if you have taken 1 digits, you are left with 4. So this slot can be filled with 4 ways. This can be filled with 3 ways, and this can be filled with 2 ways. So we are talking about the total probability, total possible ways. So 4 into 3, 12 into 4, 48. So there are 48 ways by which these slots can be filled. I mean, a number which is greater than 5,000 and the repetition of the digit is not allowed. Now coming to the probability part, it says it should be divisible by 5. Then both condition, that means greater than 5,000 but divisible by 5. Now what we know that for a number to be divisible by 5, we have two condition. It should be either ending with 0 or 5. Let's take the first condition when I have placed 0 at the unit place. Now, if I place 0 in the unit place, this slot will continue to have the two choices. That means we can place 5 or 7. So that means I can place 5 or 7 here. Considering that the repetition of the digit is not allowed, we can say that this slot can be filled with 2 ways. We have 2 choices and this have only one. Now figure out that we have fixed 2 digits, one over here and other over here. So out of this 5 digit, if we have fixed 2 of them, we are left with how much? 3 for this slot and 2 digit for this. So it comes out to be how much? This is give you 12. Yes, it should be 12. Right, this is 12. Now coming to the next condition, that is the below one. Come to the next condition, that is below one, where I have placed 5 over here for it to be divisible by 5. In that case, you can see that this slot have only one choice. As the repetition of the digit is not allowed, it can have only 7, right? It can have only 7. Now check once again that we have here too, we have fixed 2 digit, one first place, another at the end place. So you may say that for this slot, we have only, so this has one way, this has one way, this has 3 ways, right? Out of the 5, if you have fixed 2 digits, we are left with 3 and this 2. So by multiplication property, we can say 6. So now we can say that total probability is what? 12 plus 6 are the favorable, that is 18 out of the total observation, which is how much? 48. Yeah, the total is 48. Right. So it can be reduced, right? So it's divisible by 6 3 times and 6 8 times. So the required probability is 3 over 8. Now here we have not excluded 5,000 because repetition of the digit is not allowed. So we can never have a digit where even if it is ending with 5 and these zeros to make it 5,000, right? We will not have such case in the repetition of the digit.